This is a view of an abandoned human settlement, completely surrounded and slowly being swallowed by expanding sand dunes. This is land degradation in action. Across the globe, creeping deserts are rendering vast stretches of the planet totally hostile to life. Right now, up to 1 billion people are watching their local ecosystems collapse, facing the very real threat of forced migration as their home soil dies beneath their feet. While shifting climate cycles play a role, human activity is the main driver. Aggressive global warming combined with intense industrial farming practices are rapidly overexploiting the earth, turning fertile ground into dust. You can see the devastating scale of this in places like the Aral Sea, where extreme regional droughts and industrial agriculture have left massive ship hulls stranded on perfectly dry, desertified sand. Through decades of short-sighted practices, we have successfully engineered our own ecological collapse, stripping life-sustaining Earth down to an uninhabitable wasteland. But all over the world, scientists and agricultural engineers are fighting back. They are actively pushing the sand out and engineering a rebirth of the soil, proving that dead land can grow again. If you want to see exactly how human ingenuity is confronting these global challenges, make sure to subscribe so you never miss a breakthrough. Successfully reversing desertification depends on an intervention that goes beyond simple seed planting. It requires a total hack of the environment's broken water cycle. The first instinct is usually to fight nature with sheer force. This image shows massive, perfectly circular green fields that have been popping up in the middle of the Saudi Arabian desert since the 1970s. To pull this off, farmers are aggressively pumping ancient, finite water from the last ice age, tapping reserves a kilometer underground, just to grow incredibly thirsty single-crop wheat fields. The math on this doesn't add up. Monoculture farming rapidly degrades the soil's ability to retain moisture. The meager annual rainfall here can't even come close to refilling those deep aquifers. Experts calculate the pumps will run completely dry in about 50 years. Forcing agriculture with finite underground resources creates a highly visible, very temporary illusion of success. Once that ancient water is gone, the sand will simply reconquer the land. So if we can't endlessly pump water out of the ground, what if we forced the atmosphere to make it for us? This diagram illustrates a massive climate model proposed for the Sahara. By blanketing a fraction of the desert in solar panels and wind turbines, the dark surfaces would rapidly heat the ambient air, forcing it to rise. That extreme upward motion carries moisture into cooler, higher altitudes where it condenses. It becomes rain, falls over the dry lands, and could mathematically increase regional vegetation by 20%. The physics suggest a brilliant win-win for energy and agriculture, but the estimated $20 trillion price tag and the sheer geopolitical nightmare of building it make this mega engineering project a complete fantasy. The actual long-term solution relies on ancient ecological wisdom. In Saudi Arabia's Al-Baitha project, communities are using stepped Incan-style agricultural terraces to physically slow down gravity and the momentum of running water. They built kilometers of simple trenches and human-scale earthworks designed to trap violent, momentary flash floods. By stalling the runoff, the fresh water is forced deep into the ground before it has a chance to evaporate. The ecological results are stunning. They successfully restored the underground water tables. Native trees, small mammals, and birds returned. And that new plant life easily survived a 30-month drought without any artificial irrigation. By working alongside the desert's sporadic, natural rhythms instead of fighting them, we can cultivate resilient, self-sustaining life. And we know this logic scales. In China's Kubuqi desert, engineers are using specialized water jets to blast a hole in the sand and simultaneously plant and water a new cutting in under 10 seconds. They combine that highly efficient planting with low-tech protection, surrounding the young saplings with simple straw bales to block destructive desert winds while the roots anchor themselves. The regional impact is undeniable. Local farmers run profitable herbal medicine operations on once dead land, and the new green barrier has drastically decreased the massive, oppressive sandstorms that used to choke Beijing 800 kilometers away. When you pair highly efficient technology with careful collaborative community land management, Reversing macro-scale land degradation is entirely possible. So, can we stop the deserts from spreading? Yes. As this visual boundary proves, humanity absolutely possesses the tools and the knowledge to turn barren sand back into a thriving, productive grid. But there is a harsh economic reality to that success. Resurrecting dead land from scratch requires a monumental amount of human effort, complex logistics, and immense financial resources. Because of those extreme costs, ecological reclamation is a desperate, localized cure. It is practically impossible to scale this kind of high-intensity rescue to cover the 25% of the globe's soils projected to degrade by mid-century, which means our primary focus can't be on fixing dead deserts. It has to be on fiercely protecting the fragile, fertile dirt we already have. The only mathematically viable strategies for planetary health are the ones that stop the damage before it starts: curbing global warming, aggressively halting deforestation, and preventing the severe overexploitation of our existing agricultural zones. Protecting existing soil is the absolute non-negotiable baseline requirement for human survival, a necessity that goes far beyond the concept of nice-to-have environmental conservation.